So today we'll try to discuss about feature extraction. As we said in our last classes, the application of image involves three major steps. The main ones are image pre-processing and image analysis. Image pre-processing tries to prepare the image for recognition by applying like image restoration, image enhancement, normalization, skew detection, from color to gray, from gray to binary, changing the format. All those things are done given an image to come up with a better quality image which is ready for image analysis. And during image analysis, we said we are trying to, from the image, extract features that are representing the image. So basically, we are trying to identify numeric values. Those numeric values are features that are extracted to describe the image. Unless and otherwise, we create a series of numeric values that are representing an image. Since image is not directly accessible, it's very difficult to manipulate the image. So during image analysis, we have to think about image segmentation and feature extraction. Segmentation is for identifying the picture part, ignoring the background at least, or else sometimes within an image itself, there may be multiple pictures. Those multiple sub-images should be extracted turn by turn, and we have to represent each of them. So after segmentation, feature extraction is a must for representing the image, because we are trying to represent the image. We are trying to manipulate the image using its feature. The issue is what kind of feature we have to use, because maybe two or more images have the same features, or a given image may have different features, like different characters or different words have the same meaning, and the same word may have different meaning. So text we can manipulate it directly, but since images are not directly manipulated, we have to go for extracting the features properly. Especially rather than extracting one type of features, we have to mix by extracting different types of features for representation. In general, these features are divided into region-based features and boundary-based features. As we said, when we are also segmenting an image, there are region-based and edge-based segmentations. Region-based is dependent on the internal pixel distribution, but edges are trying to capture the structural setup of a given image. Here in feature extraction, we are using region for representing the image using its internal content. Image, when we are looking at its internal content, we defined in our earlier classes, images, a series of pixels that are organized in a two-dimensional space. So then we are trying to extract those series of pixels as a representation for image. Those pixels are expressing the intensity. That means a given image has color mainly. The color, because of the color difference, we divided image into three: monochrome binary image, grayscale image, and the color image. A binary image has only two colors. A grayscale image has around 256 colors, which can be combined based on the white and black colors. And on top of that, there are infinite colors we have, which can be modeled by using different color modeling like RGB. So when we go down to the internal representation of an image, by looking at the content of an image, we will get pixels, and those pixels are expressing the image. And those pixels are containing nothing but colors, intensities. And maybe a sequence of pixels are with the same color. And after sometimes, maybe you are getting another color. So in behind, there are transitions from one color to another color. In such a case, we have to go for texture. Even we can use shape and structure as a representation for image. That's the region-based representations, which can analyze the internal setup of a given image. And we can also go for boundary representation. In a boundary representation, we are trying to define based on the endpoints. Take alphabet H. It has two endpoints at the top. Take character B. It has again two endpoints at the bottom. Just by using structure, we can't represent them. Unless and otherwise, we also tell the position of those two endpoints. So boundary representation can be used, but rather than using it independently, it's better to combine it with other region representations. Even when we are simulating how human beings are perceiving a given image, what are the things they are trying to consider, or what are the things our eye tries to consider in visualizing or seeing a given object. It starts from primitive representations. Primitive representation as the basic representations that are telling us, or description that are telling us the internal content of the image in terms of especially the color. We are trying to look for the color. If the color is the same, we are trying to see the texture, the shape, that means the structure, or even the size. So the primitive features are color, shape, and texture. The major primitive feature is color. Whatever image that we are talking about, between different pictures, there are differences in terms of color. But that doesn't mean always color is different for different objects. Sometimes two individuals have the same color. Even sometimes they have the same shape. But there may be a difference in terms of texture, how the color is transiting from one type of color to another type of color to form different combination of colors that are representing a given image. Then if it's very difficult to identify using primitive, another feature is added, that is the structural feature. It also makes a difference between different objects. How can we differentiate between chair and the table, for instance? We can differentiate them based on their structure. In terms of leg, both of them are 4. But in terms of the top part, table and chairs are different. Tables are smooth, but chairs are not smooth. What about building? What about animal, plant? All of them have their own structure. Based on their structure, we can say this one is this kind of object. Sometimes we are also applying our cognitive process, like considering our feeling, considering our emotion, how our mind internally tries to interpret a given object. In addition to what is externally observed, there are feelings that we are extracting using even our nose in collecting information about a given object or a given area. Those emotions, feelings, odors are also used. So the major thing now is, if human beings are using such kinds of different future representations of an image, how can we use them for object representations? Mostly, we are dependent on the first two, primitive futures, and if you want to extract more futures, maybe you go for structural future extractions by just considering only the boundary areas of that object, to extract corners, to extract edges, to extract endpoints, then to extract the bending point of a given object. But nowadays, research is going on towards how can we also use the cognitive process? How can we make our systems understand the emotion, understand feelings, understand the others, and so on? Like there is a system for document image retrieval. Any image retrieval or any research engines are accepting users' query. Based on those users' queries, they are trying to search from the corpus or from the internet, wherever it is. And finally, they are trying to retrieve those documents in the form of text or image or video or audio for users. Now, in this case, it's a document image, content-based document image retrieval. Query is given in the form of image, and then it is trying to retrieve images related to that given query image. But the major problem is, if we are not properly trying to apply the image processing steps, many confusions may be happening with the systems that we are designing. In this case, for a given query, background is mostly dark green, but we are searching for a bird. There's a bird here, white bird, and also there are birds around here, which are a little bit far. But when we are looking at the pictures that are retrieved, most of them are not similar with the birds that we are looking for. Even birds are coming at the end at 2 points. So why the system is confused is a major thing. Maybe image pre-processing is applied, but still our future extraction is done in whatever image that we are giving it, without differentiating the background, the foreground. So if you are just retrieving, extracting features from the whole image without segmenting the image into background and the foreground, mostly since the background is dominating, the features that we are extracting from the background is dominating the features that are representing the foreground, as a result of which the system is confused. It is retrieving correctly images that are representing the background, like the background of our queries. But the difference comes is on the foreground part, the image that we are looking for. As a result, if we are extracting colors as a representation from the image, since most of the colors are dark green, the image that we are getting are also with dark green. but the objects that are available in those images are maybe plants, maybe flowers, maybe tiger animals, or plants, butterflies, and there are 2 points where there are birds. How can we improve? One of the steps that we have to take is differentiating the foreground from the background. Even nowadays, the classifier by itself starts retrieving the features that it needs for classification. But the problem happens is if we give it the whole image for the classifier like CNN in deep learning. It's trying to extract a representation from the whole image. But since the whole image is not exactly telling us the picture element, pixels that are representing the picture, then confusion will happen. So the solution is we have to differentiate between background and foreground. And we have to start searching using, or we have to start recognizing using the foreground, because our interest is in recognizing not the background but the foreground. If our interest is in recognizing the background, we have to leave the foreground and concentrate on background. So before feature extraction, we need segmentation. After segmentation, we will identify an area which is representing only the image, the foreground, the picture which is available on the background. If we represent the image using only the foreground, the picture elements that are representing the object, then we can better represent the image content. Still, maybe there are other images with the same color type, texture type. So again, maybe the shape and the structure is also the same. The solution is again, rather than just extracting the color of the image as it is and representing it with the whole colors that are identified from that object without any differentiating between by looking at the spatial distribution of the colors within the image. That means rather than just using the color, maybe we have to mix color with histogram, or even we can create a color histogram. That means we can create different regions depending on how the color is available at different points. If we try to classify even the object itself into sub-objects, depending on the color distribution or the spatial relationship that are observed within the object, then we'll have a better representation. But since, as we said, any image applications are more of requiring experiment. Without experiment, we can't decide this one is better than this one, starting from the pre-processing step. Slowly, stepwise, we have to start from pre-processing, then segmentation, then feature extraction. In that manner, then classification. We have to experimentally decide which of the combinations we have to use for segmentation, for feature extraction, for classification, for image pre-processing, like for restoring an image or enhancing the image. Then the final thing is application, because now we have a representation. So when we start applying digital image processing, we have our own objective. Plus we have there is a problem that we want to solve. The problem may be related to biometric analysis, which is related to security, solving the problem related to security. How can we secure a given person's information? Or how can we secure a given organization? Even the country. That requires biometric analysis. Can we go for face recognition? Or can we go for iris recognition or fingerprint recognition? Or signature recognition? There are many mechanisms that are available for securing a given person's information. But which one is better? As researchers said, for biometric analysis, there are different techniques applied, starting from face recognition, fingerprint recognition, even the hand vein, iris, signature, voice print, odor, DNA, ear setup, gait. But which one is better in terms of uniquely identifying a given person, in terms of permanency of that object features from time to time? Once we extract the feature of a given person, maybe facial expression or fingerprint or signature or iris, how long that feature will be static for representing that object? Which one is uniquely identifying a given object? As our age is growing, which one is more representative? Which one can easily be collected? What about performance-wise and acceptability? Especially for us, the first measurement is the uniqueness. We have to identify a unique representation for every image that we are representing. In terms of uniqueness, researchers are suggesting the fingerprint of a person, iris of a person, rental scan of a person, odor and the DNA of the person, which are unique for every individual. Which one is more permanent? Doesn't change from time to time? Fingerprint, iris, odor and the DNA. In fact, ear is also added, but the uniqueness of ear in representing is medium. In terms of performance nowadays, the state of the art shows us, in some of the cases, there is good performance level, like fingerprint, iris recognition, DNA recognition, but face recognition, which is a long back research, but still performance is very low. Why low? Because things are changing from time to time. As the age of the person is increasing, the facial setup of the person is accordingly changing. Even our expression in our face is changing. When we are happy and when we are angry, in different situations, when we have different feelings, emotions, it's dependent on our cognitive feeling, basically. As a result, face recognition is mostly one of the challenging research areas nowadays. But for solving a given problem, the immediate solution for biometric analysis nowadays are around fingerprint and iris. But the problem of iris is it has low acceptability because individuals are not ready on the one hand, and also there is a risk in taking using our cameras a given person's iris, because the light of the camera may affect the person's iris. As a result, mostly fingerprints are better in terms of acceptability. Even the voice print is also used nowadays, but it has low uniqueness and low permanence, even if it has high acceptability. So when we are selecting a given application for a given biometric analysis, we have to analyze from different point of view. So biometric analysis is one of the potential area which can help us to secure without physical appearance. Nowadays, retrieval search engines are also designed, especially content-based image retrieval, content-based even document image retrieval. Rather than searching image by text, we can design a system that can search image by image. Given an image, it can identify for you different images that are related to that image. So we can design a content-based image search engine. There are different search engines nowadays available. Even when we come to recognition of banknotes, nowadays there are fake banknotes. How can we differentiate the genuine banknotes from fake banknotes? How can we differentiate the fake cards from the true cards? Again, we have to apply image processing and come up with a system that can differentiate whether the banknote is fake or not. Even in agricultural field, we can use it for different purposes using different characteristics. Like when you come to agriculture, if you go for plants, crops, you can use the seed, you can use the leaf, you can use the soil for checking the quality of the crop. How can we check whether the coffee is with better quality? How can we check whether the wheat or sorghum is with a better quality? Which sorghum we have to use for melt? Which coffee should be exported with a better quality? To differentiate such things, rather than human beings test them, we can go for image processing to automatically test. In medical area also, there is an application. Especially the medical field is intensive in terms of image. MRIs are there, X-rays are there, CT scans are there, full of images that physicians, laboratory technicians are analyzing to identify whether a person is positive or negative. Rather than human beings are analyzing those things, because as scholars are saying, whatever is done by human being, even if it is mostly reliable and accurate, there are many problems that we are observing. Inconsistency is there, inefficiency is there, error prone. So just depending on human beings, whatever we are doing is taking time. Error prone, inconsistency is there, knowingly and unknowingly. As a result, we have to try to design a system given an X-ray or CT scan or MRI. It has to automatically differentiate whether that given CT scan or X-ray is showing positive or negative. Even the degree of positivity we can identify. Especially nowadays, agriculture is requiring image application, not only for quality checking, even which crop is more, which soil is more suitable for which crop. Why only coffee grows Harar or Jimma or different places? Is there any other place with the same soil like Harar or with the same soil like Jimma? by differentiating based on their soil, we can grow coffee at different places to make our export more strong. In addition to that, nowadays image enhancement and the image restoration by themselves are research areas, because we want to preserve our historic documents. They may be textual document, or image document, or video document. For that, unless and otherwise we enhance the image, maybe the image is blurred after digitization, or lost its quality and naturalness. So image enhancement and restorations are, again, research areas. Still, we don't have an algorithm that is as effective as possible for enhancing the image and restoring the image to the expectation. Again, image segmentation is the research area, because to what extent the image segmentation algorithm, whether it is region-based or age-based, is effective depends on the quality, naturalness of the image. As the images are degraded with low quality, naturalness, then the image segmentation starts under segmenting and over segmenting. Especially to make our image processing based systems to work in noisy environment, images that are with poor quality, naturalness, we have to design an image segmentation which is invariant to noises. The other is image compression, especially when you come to our country. Think of a document which is written in Amharic or Tigrinya, those Semitic languages which are using our own Giz or alphabet, Halahaman. If you are saving it in terms of PDF, for instance, or if it is already available in PDF, if you want to read it, we can't read. Like PDF created using Latin characters. As a result, we have to save it in image form. If you apply even for Amharic PDF, Amharic document PDF, using zip, if you compress it, it can't be compressed. Why? Because it looks the character as image. The solution is we have to design our own compression techniques to minimize the memory space requirements of those documents written in our own language. Maybe there are steps we have to go, like given a PDF document, we have to convert it into image and recognize it using optical character recognizers, and then we have to save it in textual form. For optical character recognition, we need a recognizer. That means the image should be recognized in the form of text. But the documents are not only containing textual written using our alphabet, but also images are there, tables are there, columns are there. When we are converting from one format to another format, we have to think about preserving their setup, page setup. So with those all different processes, how can we compress those documents written in terms of Ethiopic characters and save them without taking much space?